Hello friends, this video on structure of atoms part 29 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 28. Then we have something called azimuthal quantum number, that is L. And this is also known as orbital angular momentum or subsidiary quantum number. It defines the actually shape of the orbital. The first one was the shell. This is nothing but my subshells, but it defines the shape of orbital. For example, S will have this shape. This shape is for P, this is for D, and this is for F subshell. And for a given value of n, n can have values ranging from 0 to n minus 1. Right? So for a given value of n, L can have values from 0 to n minus 1. Here again, each cells consist of one or more subcells or sublevels. The maximum it can have, nth cell will have n subcells. The number of subcells is equal to n, as I told. For nth shell, the number of subcells is n. Number of orbital is n square. And each of these subshell is assigned a azimuthal quantum number. 0 is given S, 1 is given P, 2 is given D, 3 is given F, and so on. So if you see how it works is, if I take n is equal to 1, my L is L. L can have value 0 only, right? If n is equal to 2, L can have value 0 or 1. If n is equal to 3, my L can have value 0, 1 and 2, like that. So if you see, if n is equal to 1, the total number of count for L is 1, n is equal to 2, total number of count of L is 2, n is equal to 3, total number of count of L is 3, correct? 0 means S, 1 means P, this shape. That means for 1 I'll have only 1s, for 2 I'll have 2s and 2p also, correct, because 0 and 1. For 3 I'll have 3s, 1 that is 3p, and 2 that is d, that is 3d. Similarly for 4 we'll see we'll have 4s, 4p, 4d, 4f. Like that it goes on, right? For a given value of n, my L can be 0 to n minus 1. But if you see, the count is same. Same thing we are doing here. For n is equal to 0, I have L is equal to 0, right? So it's called 1s, something like this. For n is equal to 2, I can have L is equal to 0 or 1, so 2s, 2p. For n is equal to 3, I can have L to be 0, 1 or 2, 3s, 3p, 3. For n is equal to 4, I can have L to be 0, 1, 2, 3. So I have 4s, 4p, 4d. This is my S, this is my P, this is my D, and this is my F orbital. Correct? This is the subshell notation. 0 means S, 1 means P, 2 means D, 3 means F. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.